equation and its reaction, more specifically at balancing chemical equations. So we'll be looking at some examples, and let's begin. So the first example that we'll be looking at is magnesium plus dioxygen will give you magnesium oxide. Of course, when that is reacted, it will give you your product. So in order to balance this equation, what I usually do is I create a table as shown below. And I take the respective elements of each side, the reactant and the product side, to better give me an idea as to how many of each there are on each side. If there are compounds, well, we take and we break the compounds into respective elements. So let's take a look at this. Here on the reactant side, we have 1 magnesium. And we also have 2 oxygens. Usually if there is a subscript here, it tells you the amount of element there is, or they are, okay? And now let's take a look at the product side. Since we have already done the reactant side, let's take a look at the product side. We have 1 magnesium and 1 oxygen. Having this, we can clearly see that this reaction is not balanced. To make it balanced, we're going to first look at the oxygen. The oxygen on the reactant side is 2, and the oxygen on the product side is 1. To make this balance, we're going to multiply the oxygen on the product side by 2 to give you, well, 2. And now we will have 2 oxygens and 2 oxygen on both the reactants and the product side. So let's place our 2 up here. But our equation is still not balanced. Why? Because here on the product side, there is no longer 1 magnesium, but 2. We need to bear in mind is whenever there is compounds like these, magnesium oxide, when they are together, whatever we place on the oxygen will also affect the magnesium because they're together. So then we have 2 magnesium, and we need to now make the magnesium on the reactant side 2. So what we're going to do is multiply it by 2. So now we have 2 magnesiums on both sides. So let's place our 2 up here. So now our equation is balanced. Right? So now let's take a look at another example. This example is phosphoric acid plus potassium hydroxide when reacted gives you tripotassium phosphate and water. So because these are compound, we're going to now break them into their respective elements, and we're going to put it into the table form. As shown below, we have the reactant side, potassium, phosphorus, hydrogen, and oxygen. So now let's place how many of each there are on each side. If we take a look at the potassium, there's only 1 potassium. Phosphorus, there's only 1 phosphorus. Hydrogen, there is 3 and 1 here, 4. And on the oxygen, there is 4 and 1, making it 5. And if we go to the product side, we have 3 potassium, 1 phosphorus, 4 oxygen, and 1, making it 5, and 2 hydrogens. So the first thing we're going to do is balance the potassium. We're going to multiply the reactant by 3 to make them both equal. So this will equal to 3. So we're going to place our 3 up here. And as was said, whatever is placed here will affect the other two. So now, instead of having only 5 oxygens, we're going to have 4, 5, 6, 7. So remove the 5 and we're going to place 7. And instead of having 4 hydrogens, we're going to have 3, 4, 5, 6. So now we have 6 hydrogens. In order to now make this balanced, we need to multiply the hydrogen on the product side by 3 to make the hydrogens both 6. Okay? So now we have 6. Right? So now we have 3. We're going to place a 3 up here. And now we have 6 hydrogens, and we no longer have 5 oxygens, but we have 4, 5, 6, 7. So now we need to scratch that and we make it 7. So now there is 3 potassium on both sides, 1 phosphorus on both sides, 6 hydrogens on both sides, and 7 oxygens on both sides. So now the equation is balanced. Awesome. So now let's take a look at another example. This example is potassium plus diboron trioxide, and when reacted gives you potassium oxide and boron. So we're going to create our table and we're going to take each respective elements and place them into the table. So we have potassium, oxygen, and boron. Let's write how many of each there are on the reactant side. On the reactant, there is only 1 potassium. There is 3 oxygen, and there is 2 borons. On the product side, there is 2 potassiums, 1 oxygen, and 1 boron. In order to make this balanced now, we're going to multiply the oxygens by 3. So here we're going to have 3. So this will equal to 3, right? And as was said, whatever we place will affect the other elements that are inside the compound. So we no longer have 2 potassium, but now we have 6. By having 6 now, we need to multiply the potassium on the reactant side by 6 for these to be equal. So we need to multiply by 6. So we put our 6 up here. And well, finally, we have 2 borons on the reactant side and 1 on the product side. So to make this equal, we multiply the boron on the product side by 2. And now this will be 2. So now we put the 2 up here. And now we have 6 potassium on both the reactant and product side, 3 oxygens on both sides, and 2 borons on both sides, which makes this equation balanced. Let's take a look at another example. So now we have here hydrogen chloride plus sodium hydroxide when reacted gives you sodium chloride and water. As just like the others, we're going to create our table and take the respective elements of each one of them. So we have hydrogen, chlorine, sodium, and oxygen. Now let's write how many of each there are. On hydrogen, there is, let's see, 1 and 2. So there are 2 hydrogens. Then chlorine, there is only 1. So we're going to write 1. Sodium, there is also only 1. And oxygen, there is 1. And let's take a look at the product side now. Hydrogens, we have 2 hydrogen. We have 1 chlorine, 1 sodium, and 1 oxygen. If we take a look at this, all of them are the same. So we don't have to do anything here because this equation is already balanced. All right? So we don't have to put anything on these ones because they're simply 1, and well, it should already be known that all of them are 1. Very well. Let's take a look at another example. Here we have sodium plus sodium nitrite. When reacted, gives you sodium oxide and the dinitrogen. Sorry. So let's create our table. So we have sodium, nitrogen, and oxygen on both sides. Now let's write how many of each there are. Sodium, we have 2 sodiums. Nitrogen, we have 1 nitrogen. And oxygen, we have 3 oxygen on the reactant side. Now let's go on the product side. There is 1 sodium, 2 nitrogen, and 1 oxygen. As was seen before, this is not balanced. So what we're going to do, we're going to multiply the oxygens by 3. Or first, let's do the nitrogens. We're going to multiply the nitrogens by 2. So now we have 2. And here we're going to put the 2 up here. And as we need to remember, whatever we place here will affect the rest. So now there is 2 nitrogens and 6 oxygens. Okay? And now we need to balance the oxygens. Since we have 6 oxygens on the reactant side, we want 6 on the product side. So let's multiply this by 6 to give you 6. So here we're going to put our 6 here. And now whatever effects we need to place. 6 times 2 will give you 12. So instead of 2, we're going to have 12. So here we had a mistake. Instead of 1 nitrogen, there should have been 2. So we have 12, sorry, not nitrogen, sodium. So now we have 12 sodiums. And here we only have 2. In order to make this balance, what we're going to do is add 10 to make this 12. Okay? So now we have 10 sodiums, 2 sodium hydroxide, sorry, not times, 2 sodium nitrite, 6 sodium oxide, and 1 D-nitrogen. There we go. It is now balanced. Let's take a look at another example. We have now carbon plus octasulfur. When reacted, give you carbon disulfide. Now we create our table. We only have 2 elements, which is carbon and sulfur. Now let's write how many of each there are. So there's only 1 carbon, but there is 8 sulfur. On the product side, there is 1 carbon and 2 sulfur. To make this balance now, we need to multiply the sulfur on the product side by 4. So we place it 4 up here. And this will give you 8. But bear in mind, whatever we place here also affects, so this will no longer be 1 carbon, but 4 carbons. In order to balance this, we're going to, of course, multiply the carbon on the reactant side by 4, which will then give us 4. So we're going to place our 4 up here on the carbon, and then our equation is now balanced. Okay, so now let's take a look at another example. This example is sodium nitride plus carbonic acid, when reacted gives you sodium carbonate and water. So let's do our table. So we have our respective elements, sodium, oxygen, hydrogen, and carbon. And now we're going to write how many of each there are. So we have 1 sodium, 4 oxygens, because we have 3 here and 1 here. Then we have 2 hydrogens and 1, so that makes it 3 hydrogens. And carbon, we have 1 carbon. On the product side, we have 2 sodiums. We have 3 and 1, 4 oxygens. Then we have 2 hydrogen and 1 carbon. Okay, so as like before, we can see that this is not balanced, and we want to balance it now. Okay, so to make this balance, we are going to look at the sodium, and we need 2 sodiums on the reactant side to match the amount of sodium on the product side. So let's place our 2 up here. So instead of having 4 oxygens, we're going to have 3, 4, 5. So this will change to 5. And instead of having 3 hydrogens, we're going to have 2 and 2 more, which will make it 4. So now let's take a look at this side. We having 4 hydrogens, we're going to multiply the hydrogen by 2 to make it 4. So now we're going to have 4. So let's place our 2 up here. And now we have 4 hydrogens, and instead of having 4 oxygens, we're going to have 3, 4, 5. Instead of the 4, we're going to have 5. So now our equation is balanced because we have 2 sodiums on both sides, 5 oxygens on both sides, 4 hydrogens on both sides, and 1 carbon on both sides. Let's take a look at another example. At this example now, we have phosphoric acid plus magnesium hydroxide when reacted gives you magnesium phosphate and water. It might look difficult, but it's not, I promise. So let's create our table. We have hydrogen, phosphorus, oxygen, and magnesium. Let's write how many of each there are. On the reactant side, there is 3 hydrogens. No, there isn't 3 hydrogens. There is 3, 4, 5 hydrogens. So there is 5 hydrogens. There is 1 phosphorus, 4, 5, 6 oxygens, and 1 magnesium. Then on the product side, we have 3 magnesiums, 2 phosphorus, 8 oxygens, and 2 hydrogens. And my bad, we don't have 8 oxygens. Because we have 8 here and 1, 9. So we have 9 oxygens. This one is not balanced, not even close. So the first thing we're going to do is let's multiply the magnesiums. So we have 3 here. So let's place our 3 up here. So now we have 3 on both sides. Okay? And of course, the others change as well. So now we have 3 magnesiums, 3 oxygens. So 6, 7, 8, 9 oxygens. Now we have 9 oxygens. And we have 3 and 2 would be 6. So 6, 9. Okay? So now we have 6 hydrogens. Because 3 and 2 is 6. Awesome. Now, let's balance the phosphorus. We have, or better yet, let's balance the hydrogen. To make this now balanced, we need to multiply this by 6. But this will give you 12. So here. And to make this 12, we need to multiply by 2. Gonna give you 12. So here we're gonna put 2. So now we no longer have 1 phosphorus but 2. And now our equation is balanced. We have 12 hydrogens on both sides, 2 phosphorus on both sides, 9 oxygens on both sides, and 3 magnesiums on both sides. Okay? Very well. Now let's take a look at another example. So this one is calcium phosphate plus silicon dioxide plus carbon when reacted gives you wollastonite plus carbon monoxide and phosphate. Sorry, phosphorus. We're going to create our table. You have carbon, phosphorus, oxygen, silicon, and carbon. We have 3 on this side, calcium on the reactant side. So let's write 3. We have 2 phosphorus, then we have 8, 10 oxygens, one silicon, and 1 carbon. All right? On the product side, we have 1 calcium, 1 potassium, 4 oxygens, 1 silicon, and 1 carbon. So this is not balanced. In order to balance it, of course, we need to make some adjustments. So let's multiply the calcium by 3. So now we have 3 calciums. We're going to put the 3 up here, and that changes things. Where we'll no longer have 1 silicon, but 3. And we will no longer have 4 oxygens, but 3 and 3, 9, 1, 10. So we'll have 10 oxygens. Very well. Now, let's take a look at the silicone. There's 3 silicones on the product side and 1 on the reactant side. So let's make it 3. And we know that to make it 3, we need to multiply by 3 to give you the 3. So now we have 3 silicon dioxide. Our equation is still not balanced because now we have different numbers in the reactant side. We have 3 silicones, but oxygens, we have now 8, 11. Okay, we have 11 on the oxygen. Because 2 by 4 is 8. Then we have, oh, not 11. Sorry, guys. 2 by 8 is, 2 by 4 is 8. And then 3 by 2 is 6. So that makes it 14. So we have 14 oxygens. And to balance this now, we will add okay? We will add here by 5. There was a mistake here. It shouldn't have been thin. Okay. Should have been 9. Which then this will equal to 14. So we're going to have 5 here. Okay? So now the carbon changes, where we'll have 5 carbons. To make the carbon the same on the product side, we need to multiply by 5 here on the reactant side. So we're going to have 5 here. And if we take a look at the phosphorus, there is 2 here. So now we need to multiply by 2 on the product side to make this equation balanced. And now the equation is balanced. Here on the oxygens, let me explain to you what happened here on the oxygen. At first, we began with 8, 9, 10 oxygens on the reactant side. And on the product side, we began with 3, 4. Then, when we placed the 3 here in front of the silicone, it made 6 oxygens. Then 6 and 8 will give you 14. Here, 3 and 3 is 9. So there should have been 9 oxygens here. Okay, because 3 by 3 is 9. Then we added 5, which is this here, which this will give you 14. And there you go. That's what happened here. So if I made it a little bit confusing, I apologize, but that was what happened. And that now makes your equation balanced. Now I have some questions for you to solve. So this is your practice. And I will be giving the answer in 5, 4, 3, 2, 1. If you need more time, well, clearly you will. You can pause the video and and the answer will come out in, well, right now. So these are your answers. If you had that, very well, you understood the entire balancing of chemical equations. And well, if you want a specific video, you can comment down below and I'm gonna create a video explaining you on your request. For now, this is all, and hope you all understood, and good luck. Bye.